Okay. In the previous we have discussed a priori algorithm, and in today's class we are going to see happy growth algorithm. I think my voice is visible. Voice is audible. Please respond.
Yes, yes, sir.
Yes, sir.
Okay. So using the a priori algorithm, we need to generate a candidate item set, and these item sets may be large in number if the database size is very huge. And in a priori algorithm, we need to do the multiple scanning operations of the database to check the support count of each item whichever is generated, which leads to high complexity and high cost. So these shortcomings can be overcome using the happy growth algorithm. So happy growth algorithm will find the frequent patterns without candidate generation. So that is the advantage of happy growth algorithm. So what is happy growth? The frequent pattern growth algorithm. Happy means. Now, frequent pattern growth algorithm, which is used to find the frequent items sets without candidate generation. First, compress the database representing frequent item sets into frequent pattern tree, which is known as FP tree, which retains the item set association information in tree format. Second, we are making use of the compressed data we are dividing, which is called as a conditional database, each associated with the one frequent item or one frequent pattern fragment, and which is used to mine the database separately. Now, frequent pattern tree is just like a tree structure that is made with the initial item sets of database. The purpose of FP tree is to mine the most frequent pattern. Each node of the FP tree represents an item of the item set. The root node represents null, while lower nodes represents the item sets. And the association of the nodes with the lower nodes is also maintained in this tree. Now let us see this with an example. Now given a transaction set, you can see a transaction set on the screen. You can note it down quickly. Are you listening? You can note it down this. Transaction IDs are given 100, 200, 300, 400, 500. And corresponding frequent items, whatever the items are purchased in this transaction. So monkey, DONKEY, make, monkey, cookie. So this is a typical example which is taken from your textbook exercise. And the minimum support is given as a T. Okay. So I think you are noted down this. Please reply.
Yes, sir.
Okay. So next step is we need to write these items with its support count. Now these items along with this support count, we need to write items and support count. So now first item is M. So how many times it is occurring? 1, 2, 3. That's why we have written 3. O, which is occurring 3 times. N occurring 2 times. A occurring 5 E occurring 4 times, Y occurring once, E occurring once, A only once, U once, C 2 times, and I, cookie, I, here it is. So here it is I. So I is occurring once. Next, we need to eliminate those items whose support is less than minimum support. So that's why this can be eliminated. And this can be eliminated, this can be eliminated. So all these can be eliminated. Then we need to write the frequent items in reverse order of their support. Means whichever is having highest support, that need to write first. So now here highest support is K. So write the item along with the support count. So K 5, E 4, M 3, O 3, Y 3. So like this we need to write the frequent patterns whose support count is greater than or equal to minimum support. I hope you are writing this.
So,
Yeah, write this quickly, and once you finish, quickly tell me, because we are running out of time. And
Yes, sir.
okay. So next is write this item ID, support count, whatever you have written. Now we need to draw a tree. So this is called as a FP tree. Now this FP tree can be drawn so based on a transaction. Now here, if you are observing here, it's okay. So how many times so K is occurring? Once again, let me. Okay, before that, um, okay, here we need to write. Okay, here we need to write ordered item set. So I have not written this. Ordered item set. Now here in this order only we need to write the items. So which item is present here? A. Next is E is present. Yes, E is present. Next is which item? M is present. Yes, M is present. Next is O is present in this. It's present, right? O. Next Y is present. It's present. So right. So this is ordered items. K-E-M-O-Y. In this order only you have to write. First we have to see whether K is there. Is there? No? It's in this transaction. So write K. Next, see whether E is present. In this order. K-E. E is present. That's why I write it. Next is M. M is present. S. Next is O. O is present. S. Next is Y. Y is present. Yes, Y is present. For this second transaction, we need to write first K is present or not. First one K. K is present or not. It's present. Write K. Next is E is present or not. E is present. Write E. Next is O is present or not. O is present. Next, Y is present or not. Y is present. Right. Now next is we need to check K is present in this transaction. This K is present. So next is E is present. Yes, E is present. Right. E. Next is O. O is not present. Sorry, M. M is present right here. M is there. Right, M. Next, O is present, not present. Y is present, not present. So next is in this transaction, whether K is present in this one, K is present. So next is M is present, E is present, not present. M is present, it's present. So write M. Next is O is present, not present. So next, Y is present, yes, Y is present. So write this. So next in the last transaction, transaction 500, K is present, yes, K is present. Next E is present, yes, E is present. E is present. Next O is present, yes, O is present. M is not present, Y is not present. I hope you have written this ordered item sets.
Yes.
In front of the item sets only write this. K-E-M-O-Y, K-E-O-Y, K-E-M, K-M-Y, K-E-O. I hope you have written. So based on the frequency, so now here highest frequency you need to write first. Frequency means it's support count. Whichever is having support count largest, that you need to write first. So K is there, E is there, M is there, O is there, Y is there. You understood this how to write, no? This part.
Yes, sir.
Okay, let us continue then. Now take this first transaction. I ordered item set KEMOY. Draw the tree. So from the null KEMOY. Write its corresponding frequency or support count. How many times it is there? Only once. Here once, here once, K is once, E is once, M is once, O is once, Y is once. So what we are doing is we are drawing a tree. We are drawing a tree starting with the root node null, and here we are creating a data structure, and we are connecting a some are getting invalid password. The password is valid, I guess. That is I think I've shared. Some students are facing some problem of invalid password, right? The password is also shared, right? Otherwise, you can click on that link. Link I've shared in WhatsApp. Otherwise, let me tell the password. It's 5Z OTC O. It is O, capital O, not 0. 5Z. 5Z. It's a capital O T C capital, and it is I, not 1. So, Prajna, please inform this to your classmates. Because this is a very
Okay.
important, yeah? Prajna?
Okay.
Yeah. Because this class is very, very important. Now, from the previous, I think you have noted down that ordered item set, right? Now, first transaction, A is present. That's why create a node and establish a link from this data structure. Create a node and create a node link from this data structure. Okay. So K equal to K once it is occurring. After K, E is present in the ordered item set, right? E is present in the ordered item set. So that's why E frequency is once. Next, M is present, right? In the ordered item set. M is present. That's why M create a node and create a link, and its frequency is 1. And O is present and create a node, node, and the item is O and its frequency is 1. Then create one more node Y and its frequency is 1, and connect the node link from here to the T, this node. Now connect this. This is a path. So order item set is initially nothing will be there. Then K, E, M, O, Y. How we got? How we got this answer? How we got this? How we got this? Are you there?
Yes, sir.
Understood, no?
Yes.
Remaining students are not answering.
Yes, sir.
Understood, right? Okay. So for the next ordered set, which is the next ordered set? Ordered item set, which one? AEOY. Correct, no? This one. Are you there?
Yes, sir.
AEOY. So A is present. A is present. So K will be increased to 2. E is there. Right. KE. Next is O. So O is present, but M is not present. That's why K will be increased to 1 to 2. E is increased to 1 to 2. And we need to create one more node. So O with the support or frequency 1. Then Y is present, right? So we can write here, and you can connect this from this. So O is 1. Again, one more O. So O 1. So this is the second order set. That is KEOY. I hope it is clear to you. Yes or no?
Yes.
Yeah, KEOY. So next ordered item set is KEM. Yeah. So now how to write? So K, increase the value to 3. E 3. So M is increased by 1. Earlier it was 1. Now it is become 2. KEM. M become 2. Hope it is clear.
Yes, sir. Yes, sir.
Okay. Next order item set is KMY.
Bye.
So now A will be increased from 3 to 4. K. Next M. So that's why we cannot directly connect this to M, right? That's why create a node and connect this to this, link to this. So created a new node K, then M with the frequency 1. Next is the Y. So Y. So K, M, Y. So we have created the nodes, and this is the path for K, M, Y. Next is ordered item set is K, E, O. Right. So that's why we need to increase the K value. So K is increased from 4 to 5. So K. Next is E. So E, earlier it was 3. Now it become 4. Next O. O earlier was 1 here. Now it is increased to 2. Is it clear? AEO. Is it clear?
Yes, sir.
Okay. So this is called as a frequent pattern tree. Frequent pattern tree. And using this tree, we need to generate the conditional pattern base. Now, the tree is drawn. And what we have to do is, here we have drawn the items, not item ID here, just a correction. Item is KEMOY. But while writing in the conditional pattern base, we need to write this in a reverse order of the frequency. Reverse order of the frequency we need to write. So you are writing now, or you will see this. I think you have taken a pic or something using mobile or some other by means, or you have taken a snapshot, because this is very, very important. Tell me, give me your answer.
Writing, sir.
Writing. So you want to write this one? This page? So write this page. So you'll be able to understand. And if you are having any doubt, you can ask with me. So quickly you write, because the meeting duration is only 40 minutes. Okay, done.
Yes.
Okay. So next is, we need to write this in a reverse order. KEMOY is there, no? And we need to write YOMEK. So in the conditional pattern base, we need to write in a reverse order. So conditional pattern base is the path by which we can get these items. How, which path we need to follow in order to get these items. So in order to get Y, which path need to be followed? In order to get O, which path need to be followed? Now first, in order to get Y, one path is we need to use K, E, M, O. So I am not connected here, just a connection. So KEMOY. So in order to reach Y, I can use a path KEMO. KEMO. So, and the how many times it is occurred? It's occurred only once. That is the frequency. Next is, we need to write how to reach Y. Now, is there any other path? So K, E, O, I can reach Y, right? So that's why we need to write KEO. So I can reach using this path, KEO. So next is, is there any other path so that I can reach to item Y in this tree, FP tree. So K, M, I can reach Y. So write this, note it down. Okay. Similarly, for O, so I can reach O using K, E, M, one path. Once it is occurring. Next, one more is K, E. I can reach O. So K, E, I can reach using 2 times I can reach, because by looking at this ordered items that I can make out here, KE is occurring twice, so I can reach 2 times. So that's why its frequency is 2 here, KE 2. Next is I can reach to, how I can reach to M. So first is KE. So 2 times I can, because KM is occurring twice in a ordered item set. So KM twice. So KE. So by KE, I can reach M. KE, M. So that's why KE twice. Then here I can reach to M, item M, using directly K. So frequency is only once. K once. So now next E. E I can reach 4 times. 4 times I can reach. Oh, by K. So once the K is going this way, remaining all 4. So that's why K 4. Now next is conditional FP tree. Only 10 minutes are remaining. So conditional FP tree. Now here we need to see how many items are having support 3 or more. Now here A is only occurring twice. Other items, how many times? E only twice is there. O only twice. M also twice. Need not write. So conditional FP tree, A colon 3. Its frequency is 3 times. So next is O. Okay, next is in this item O, conditional pattern base we need to see, and which are the items which are occurring 3 times. Now M is occurring only once, but KE is occurring 3 times. Once here KE and 2 times here. So total 3 times. That's why KE is 3. In the conditional pattern base, KE occurrence is 3. Now next here we have to see whether it is having 3 or more support. So K, E 2 times here, K once only. So here we can take K 2 times plus 1, 3. So that's why K 3 times. So next is K, only one is there. K here at least 3 times is required, minimum support. That's why K 4. Okay, I can try. Now next is how we can generate the frequent pattern. First we need to see here, we need to write all the sets from this, all the possible sets, and here their frequency to reach Y. So now Y, how I can reach? So K and Y 3 times. Now here we have to see K, the combinations we can see. One is K and O, right now, K and O. Then E and O. Next is KEO together. I hope it is clear to you. Please give me the answer. Huh?
Yes, sir.
Okay. So next is we need to see M. So M, here M and K. Only possibility M and K. M and K. So 3 times. Next is K and E. A, E, 4 times. So once we have generated this sequence patterns, the next step is to generate the rules. Now K is there. K is there. From that, how we can write the rules? In the a priori algorithm, we have generated the rules, right? Two items are given, sequence items. So now KY. Now the rule is K implies Y or Y implies K. But we need to count the support. We need to count the confidence. You know how to count the confidence. I think we are already aware. So support count of K and Y together. Support count of K and Y. K and Y is 3 divided by support count of only K. K where it is given support count K is 5. So that is the confidence. So 3 by 5. What is 3 by 5? 60%. Right, 0.6. 3 by 5 is 0.6. So 60% confidence. So similarly, I have to see by K. So confidence, how to compute? Confidence equal to support count of K and Y together. K and Y is 3 divided by support of Y. What is support of Y? 3. 3 by 3 is how much?
1.
100%. 100%, right? Percentage wise 100%. That's why I can choose this as one rule. Similarly, I can generate from this KO, EO, OEK. So now K to O, O to K, E to O, O to E, then O, E and K in right hand side, O and E, K is right hand side. And for each and everything, I need to find the confidence value. The confidence, minimum confidence is given as 80. Whichever items are having more than or equal to 80%, they will form the strong rules. Strong rules. Now, similarly, M and K. This is understood, right? O, E, K. Possibilities is O is E and K. One possibility. Second possibility is E. If you have taken E only, then what are the combinations? O, K. Check now. Rules. Next is take only K here. Then O and E. Similarly, take O and E. O, E. Sorry. O and okay. If you have taken O and E, then K. Okay. Next, this one only. Same thing we can write. Then E and O and K. O, K. Right side E. Then next is EK. Right hand side is O. For each and everything, we need to determine the confidence. So confidence is given by confidence of O, E, K together. So 3 divided by confidence of O. What is the confidence? So what is sorry support of O? What is support of O? Well, this is 3 by support of O.
3.
Support of O is 3. So this becomes a strong rule. Likewise, we need to find the confidence, determine the confidence, and finally we need to determine the strong rules. So association rules can be generated based on two techniques. One is using a priori algorithm and second is based on the FP growth algorithm or FP growth technique. So in FP growth technique, basically there are two major steps. First step is to generate the FP tree. From that FP tree, we need to generate the conditional pattern base. Once conditional pattern base is created, then we need to see the support and we need to do the conditional FP tree. From conditional FP tree, we need to generate the frequent patterns. Once the frequent patterns are generated, the next step is to generate the strong rules. And the strong rules steps are same as that of we have discussed earlier in the a priori algorithm. That is confidence value need to be computed, and we need to determine we have to take one threshold confidence, minimum confidence level, and whichever are the items or rules which are having higher than confidence, minimum confidence, they are called as a strong rules. I hope only 1 minute is remaining. If you are having any doubt or anything, you can ask me, or you can send and you can communicate with me through WhatsApp. I hope it is clear to you. Yes or no?
Yes, sir.
Whether it is useful or understood something.